All right, you guys, problem number 43 is one I debated whether I should assign or not. And it's definitely a hard problem. In no way, shape, or form should you feel bad if you needed some help on this one. This is not one that's going to show up on a quiz or a test, but it does kind of give you a little hint as to a method we're going to be using later on in the year for evaluating some tough integrals in the second semester called U substitution. So I figured, what's the harm of putting this in here? So we're evaluating a limit as h approaches 0 of, oh boy, this looks like fun, the fourth root of 1 plus h minus 1 all over h. Okay, first thing to think about is plug and chug, but not surprisingly here we end up with a 0 on the bottom and a 0 on the top for that matter, so direct substitution doesn't work. And you can't really factor or expand that fourth root of 1 plus h, so I can see if you got here and had no clue what to do. But they did give you a little hint off to the side. I'm going to switch to green here, and we're going to use that substitution. So the hint that they gave us off to the side is to let x equal the fourth root of 1 plus h, okay? And so we're going to take this mess out right here and just turn that into an x. Now, I haven't made clear yet what it is that's going to accomplish, but humor me for just a second now, guys. This is now going to be a limit as, and I'm going to leave the bottom part here blank. What our goal here is we're going to try to change everything in this problem from being in terms of the variable h to now being in terms of x according to this definition of x right over here. So let's see what we've got. X is equal to the fourth root of 1 plus h. So this whole first term right here just becomes an x, and then there's a minus 1 at the end of all that. Well, okay, my numerator is a lot simpler now than it was a moment ago. But it doesn't do me any good to put an h down here or a limit as h approaches 0 out in front, because now my variables are mixed. I've got two h's, cool, but now an x right here. That doesn't help at all. So the goal is to turn everything from h into x, starting with this right here, guys. All right, we're going to do to see what we can do to express that h in terms of x. So I'm going to do a little algebra on what I have right over here in green, trying to solve this equation for h. The first thing I would do is take both sides to the fourth power. X to the fourth then would equal, and the fourth power and the fourth root cancel each other out, and that's just a 1 plus h. And now I'll subtract the 1 from each side and get h is equal to x to the fourth minus 1. That was my denominator, h. So I can now replace that h with x to the fourth minus 1. Okay, x to the fourth minus 1 would go right over there. The only thing we still have to consider now is what's going on there, guys, with a limit as h approaches 0. So what I would probably do is focus on turning that h value into an x value according to this definition right here. If h were to equal 0, let's think about that. 1 plus 0 would be 1, and the fourth root of 1 would be 1. This would be the same now as having a limit as x approaches 1. Because when I put a 0 in for h here, I got a 1 out for x. So this is what substitution looks like. We've taken everything that was in terms of h and gotten everything expressed in terms of x. Now hopefully the limit that we now have to evaluate is a little bit simpler than the one that we started with, and it does look better, although of course we still have the same huge problem. We can't do direct substitution here because 1 minus 1 would still get us 0 in the denominator. But the hope would be that what you're dealing with now, that I have here in blue, is easier to deal with than what we initially had in black. And let's be honest, what scared all of us when we saw this problem at first was the fourth root. Well, that's gone now. So where can we go now? It doesn't look super simple, guys, but this is actually just a factor and cancel problem now. The numerator, x minus 1, you can't do anything with. The denominator, though, x to the fourth minus 1, is a difference of squares. So that factors into, here we go, the product of two binomials. The square root of x to the fourth is x squared. That goes here and here. Conjugate binomials have the same first term, x squared and x squared, but their signs now are opposites, 1 plus and 1 minus, and the square root of 1 is, of course, 1. So that's how that denominator factors. Now, does plug and chug work here? No, it doesn't, because when you put the 1 in right here for that x, you still end up with a 1 minus 1, which is a 0 on the bottom. But which you may have noticed here a second ago. Let me see if I can shrink this down, everybody. Hang on, there's a shortcut for this. If I draw a little line right over here, now I think I can zoom in. Yeah, that'll work. Okay, now in the denominator, this x squared minus 1 is still another difference of squares, and we can factor that further. So this is now a limit as x approaches 1 of, and here we go, the numerator stays x minus 1. In the denominator, x squared plus 1 is a sum of squares. That doesn't factor at all. There's nothing you can do with that. But the x squared minus 1 is going to factor into an x plus 1, and an x minus 1. And now the entire numerator cancels with that x minus 1 on the bottom, and now I think plug and chug is going to work. When everything in the numerator cancels, it leaves us with a 1, and down in the denominator, 1 plus 1 is going to be a 2, multiplied by 1 plus 1 is going to be another 2. Oh, that's it, guys. And our answer here for number 43 ends up being 1/4. So let me say again, that is definitely kind of outside of the realm right here of what normal problems would look like, and I wouldn't expect at all that you guys would know how to do that one on your own, but hopefully now that we've walked through it, it makes a little bit more sense, and if you see a problem like that in the future, you'll have some clue what to do with it.